So, so far we've learned two ways of graphing, or not graphing, but solving systems of equations. Graphing was one of those methods, and substitution was the other. The third and final method that we're going to learn for solving systems is called elimination. The reason why there are different methods is, first of all, graphing exists so we can have a visual representation of what we're doing. And then between substitution and elimination, it just kind of depends on what information you're providing. One method might be simpler than another to use depending on how the equations are written. So that's why we have those two kind of algebra methods. And we're going to learn the second algebra method today with elimination. So today is like the ultimate Tuesday, right? Like all twos, literally Tuesday. So that's what we've got going on today. All the twos are happening. So the elimination method is, let's go ahead and write this down. It is a method for solving systems and remember that systems, our definition of a system of equations was just solving for two variables in two equations. That's what a system is to us. And we're going to be solving these systems by adding or subtracting to eliminate a variable. So we're going to be working on our first day of elimination today. We're going to finish these notes today. You'll have an assignment tomorrow. We're going to add on a little bit of complexity to this process. And then Thursday, we are going to review all three methods, just so we can review and remember what we're doing with graphing, substitution, review what we're doing with elimination as well. So the elimination method is a method for solving systems by adding or subtracting to eliminate a variable. And by the way, these notes, with the way that we're going to be using elimination today, these are actually not going to take all that long. First period, I think, had a half an hour of work time. So I'm hoping that you'll have the same and maybe get to finish or get close to finishing your assignment today before we even leave. So it's a method for solving systems by adding or subtracting to eliminate a variable. The object is still the same though. We're solving for X, we're solving for Y. The objective between all three methods is exactly the same. Where do the two lines cross? Write your answer like a point on a graph. So the steps to solve, you'll see there's 4 steps here. The first step says to make sure that the equations are lined up. This is a very different start to what we did with substitution. Substitution, we had to make sure that a variable was by itself. With elimination, we don't have to guarantee that. Even though on example number 1, you do see that y equals is by itself on both of these equations. But the important thing with elimination is that all of the equations are lined up, meaning y's are stacked on y's, x's are stacked on x's, regular numbers stacked on regular numbers. And the entire first page is like that. X is stacked on x's, y stacked on y's, numbers stacked on numbers. And it doesn't matter how the equation is written, as long as you have those things in place, you can use elimination. With example 1, though, we would actually have an option between substitution and elimination because we solved substitution like this. We solved equations like this using substitution. Today, I'm going to show you what elimination looks like with that. So step 1, make sure that the x's are lined up on top of x's, y's are lined up on top of y's, regular numbers lined up on top of regular numbers. Step 2, exactly, is to add or subtract. Add or subtract the equations to eliminate the variable with common, and the word here is, the common number in front of x and y, which is called, or the number in front of x or y, and that's called a coefficient. So common coefficients. And again, these are just the numbers next to variables. So a number next to a variable is called a coefficient. And so as long as you have coefficients that are matching, which today we will have matching coefficients all the way through today's lesson. The difference tomorrow is that we're not necessarily going to have matching coefficients, which kind of increases the complexity just a little bit. But we don't have to worry about that today. So for example, if we look at problem number 1, the coefficients with y are both 1. So those are common coefficients. On number 2, the coefficients with x are both 1. So those would be the common coefficients. On number 3, the common coefficients are with x because they're both 3. On number 4, the common coefficients are with y because they're both 2. And so as long as you have the same number with x or with y, you can use elimination. And step 3 is to solve. Step 3, solve for the remaining variable, because when you eliminate, you actually get rid of one of your 2 variables. It goes away completely, and then you can solve for the one that's left over. Step 4 is basically the same as the last step with what we did with substitution. So step 4 is to substitute. Substitute your answer into either original equation. It doesn't actually matter which one you plug it into. It didn't for substitution either, but it was always easier to plug it into one or the other with substitution. Today, it's not necessarily going to matter in terms of difficulty. So substitute your answer into either original equation and solve for the other variable. So it is likely, before we start, it is likely that this method today anyway will feel a little bit simpler than substitution. But that's because you will have a common coefficient with every single problem. When we get into the type of elimination that we're going to use tomorrow, it'll probably have about the same difficulty level as substitution did last week. So these definitely set up a little bit different though. So let's have a look at example number 1. So we're going to use elimination on this one. We could use substitution because we used substitution last week on ones like this, but since we're practicing elimination today, we're going to draw a line underneath both equations. And the reason why we're doing that is because we're basically setting this up as an addition or a subtraction problem, kind of like what you did like back in grade school, except now we're dealing with 2 equations as opposed to just adding or subtracting numbers. I'm going to go ahead and put a 1 in front of the y's, and I'm going to put a 1 in front of the x just to remind myself that that is the number with it. That is the coefficient with those variables. If there isn't a number shown with the variable, the number is 1. All right, now we have to determine. So step 1, make sure the equations are lined up. We've got that. Step 2, add or subtract the equations to eliminate the variable with common coefficients, meaning we got to get rid of the y's. We have to cancel these out. So how would we cancel out the y variables? Would we add them together or would we subtract them if we're going to eliminate them? You're saying subtraction? Yeah, because if we added a 1y and a 1y, that wouldn't get rid of them. That would make a 2y. Now, there's nothing wrong with adding. It just doesn't help us to solve. We could add, it just wouldn't be helpful. So if we subtract, that's going to be our operation here. So we're going to put subtraction off to the side. And we are going to subtract every like term. So the 1y minus the 1y, those will cancel out entirely on the left-hand side. And when you have nothing, you just write 0. So 0, we still have an equal sign in the middle, equals. And then we're just going to keep subtracting from left to right. So 3x minus 1x is exactly 2x. So 3x minus 1x is 2x. And then the last one here, we do have to think about this one because it's not 4 minus 2. This is a negative 2. It's 4 minus negative 2. And subtracting a negative is always the same as adding. So it's actually 4 plus 2, which is positive 6. So when we subtract those 2 equations, we end up with 0 equals 2x plus 6. And this kind of achieves the same purpose as substitution. It gets rid of one of our variables and allows us to solve for the one that's left. And so to solve for x now, we have to get the 6 away from the side that the x is on. So we're going to subtract 6 from both sides, minus 6. 0 minus 6 is negative 6. And that equals 2x. And we have one last thing to do. We have to divide by 2 to get the x by itself. So divide by 2 on both sides. Negative 6 divided by 2 means that x is equal to negative 3. So we've solved for x. We've gone through step 3. We made sure the equations were lined up. We subtracted specifically to get rid of the common coefficients. We solved for the remaining variable. Now step 4, the last step, substitute your answer, -3 for x, substitute it back into one of the original 2 equations, and then solve for the other variable. So first person I see, hold up a 1 or a 2 in terms of which one we're going to sub it into. Number 1. Okay. So we're going to sub this back into the first equation. We could have put it into the second one, doesn't matter. So we're going to use y equals 3x plus 4 to solve for y. And this is going to look just like what we did with substitution. We're going to take our -3. We're going to substitute it in for x on that equation. And so that'll give us y equals 3 times -3 plus 4. And then we just solve the right side of this equation. No algebra needed on this one. We will have to use algebra in some cases to find the second variable, but not on this one. 3 times -3 is -9. -9 plus 4 is -5. So y equals -5. So we have our answer. We have a -3 for x and -5 for y. We write this as a point on a graph because that's what it is. Meaning if we were to graph those 2 equations on the graph, they would cross at the point -3, -5. That's our answer for the first one. So as long as you have your variables lined up, and as long as you have a number in front of one of the 2 variables that's the same, you can eliminate one of your variables to solve for the other one. Any questions before we look at example 2? All right, here we go. Problem number 2. Anything that's a variable by itself, again, I'm just going to put a 1 in front of it. So 1, 1, and 1. So I'm putting 3 1s in this one as well. Most of the time, you will use elimination when things are in standard form. That is what we're looking at with number 2. Ax plus by equals c. So standard form is what you're going to use most of the time. If I were actually solving number 1, I would probably use substitution. Like if I had a choice in the matter, I wouldn't usually use elimination to solve a problem like number 1. I would go with substitution. But since it tells us to use elimination, we did. Most of the time you use elimination though, standard form will be the type of equation that you'll see most often. So we're going to go ahead and put our line underneath here because we have our variables lined up. X's on X's, Y's over Y's, numbers over numbers. And we have a common coefficient 1 and 1 with our X's this time. And so if we want to get rid of the common coefficient, the 1 in front of each X, would we have to add these 2 together or subtract them? If we want the X's to go away, would we add the X's or subtract them? Subtract them, yeah. 1 minus 1, again, is 0. So we're subtracting this time. The variables, the X variables cancel out altogether. So those are gone. We don't have to write 0 this time. The only reason we wrote 0 on the previous problem is because that was the only thing on that side of the equation. This time, the X's and Y's are together on the same side. So we don't actually have to write a 0 underneath here. And then we're going to take 4 and we're going to subtract -1. 4 minus -1 is the same as 4 plus 1. So that's 5y. And then 13 minus 3 is 10. So we have an equation that says 5y equals 10. So the x is canceled out. 4 minus -1 is 5, so 5y, and 13 minus 3 is 10. So 5y equals 10. Now to solve for y, we just divide both sides by 5. And y equals 2. So we got one of our 2 variables. Y equals 2. Now we have to solve for x. And we're going to plug in the value of y, 2, back into one of the 2 original equations. So 1 or 2? 1. Okay. First equation then. This will be x plus 4y. So we're plugging into the first one. X plus 4y equals 13. This time we have the value of y. So we're going to plug in for y and solve for x. So I'm going to take my y equals 2. Drop it in for y this time. And we're going to say x plus 4 times 2 equals 13. This one will involve a little bit of algebra this time because when we multiply 4 times 2, we get 8, and that's x plus 8 equals 13. but we still have to get x by itself. So here's our one step of algebra here. We have to subtract 8 from both sides. So minus 8 minus 8. 13 minus 8 is 5. So that means that x equals 5. So we have x equals 5. We have y equals 2. Remember that when you write your answer in parentheses, it's always x first, then y. So we're looking at 5, 2 as our answer for number 2. Are there any questions so far? So I'm going to help you get started on number 3, and then I'm going to have you finish it up on your own. So here we go. Number 3. We have our equations all lined up. X's over x's, y's over y's, numbers over numbers. So we're good to go ahead and just start eliminating because we do have a common coefficient here with our x's again. 3 is in front of both of them. So would we add these together or subtract them to make the x's go away? Subtract again. Yep. So the first 3 problems we're subtracting. And when we subtract through, the 3x minus 3x, those will cancel out altogether. And then we're looking at negative 10 minus negative 9. That's a lot of minuses and negatives there. Negative 10 minus negative 9 is the same thing as negative 10 plus 9. Negative 10 plus 9 is negative 1. So it's negative 1y. And then 14 minus 15 is negative 1. So negative 1y equals negative 1. What I'm going to do now is I'm going to give you a couple minutes. I want you to solve for y, and then I want you to use y and solve for x. So finish this problem up on your own, and then we'll move on after that. All right, what does y equal? Just 1. Yep. So to get y by itself, just divide by negative 1 on both sides. Negative 1 divided by negative 1 means that y equals 1. Great. So let's see. First equation or second equation? Which one should we plug into? First one, okay? This time I'm not going to rewrite the entire equation and then do the circle and the arrow. I'm just going to rewrite it with the value of y. So we got 3x minus 10 times the value of y is 1. So I'm going to write minus 10 times 1 equals 14. So just rewriting it with the y in there instead of rewriting the whole equation with the circle and the arrow, just setting it up a little bit quicker. 3x minus 10 times 1. 10 times 1 is 10. So 3x minus 10 equals 14. And we're going to add 10 to both sides. So plus 10, 3x equals 14 plus 10, which is 24. And then the final step to get x by itself, divide both sides by 3. And x equals 8. So y equals 1, x equals 8. So the answer is, making sure that the x is first inside the parentheses, 8, 1 will be our answer. That's it for number 3. Double check your answer. Make sure you have this. Did anybody use the second equation to solve for x? Use the second equation? No? Okay. If you use the second equation, the answer should still be 8 for x. All right. Let's see. Cross off number 4. Cross that one off. We're not doing number 4. Cross off number 4, and then let's move ahead. Look at number 5. All right, here we go. Number 5. So number 5, our x's are lined up, our y's are lined up, our regular numbers are lined up, so we're good to go there. This time the common coefficient is with the x's again. However, this time we have a positive 4 and we have a negative 4. So if we want to make the x's eliminate, should we add these or subtract them? We're actually we're gonna add them this time. The reason is because if you have a positive and a negative of the same value, if you add a positive and a negative, if you add opposites, positive 4, negative 4, that's going to equal 0. So if you have opposite values, positive and negative of the same number, add the two equations together. If it's the same, if they're both positive or both negative, then you would subtract them. So this time, this is our first one where we're adding. So 4x plus negative 4x, that's 0. So those cancel out. The x's are gone again. 9y plus 7y. So we're adding this time. 9 plus 7 is 16. So that's 16y. And then 5 plus 11. So 5 plus 11 is 16. So you get 16y equals 16. All right. So it's the same value of y as the last problem then. Divide by 16 and y equals 1. All right. We got y equals 1. Now we need x. First equation or second equation? 1 or 2? Second one. Okay. I saw a second one. So we're going to do negative 4x plus 7 times the value of y is 1. I'm going to write 1 instead of y. Sorry. So 7 times 1 equals 11. That's a 1 in the parentheses. So 7 times 1 is 7. So that's negative 4x plus 7 equals 11. And then we're going to subtract 7 from both sides to get the negative 4x by itself. Negative 4x equals 11 minus 7 is negative 4. Divide both sides. Oh, sorry, it's positive 4. I don't know why I wrote negative 4. Positive 4. 11 minus 7 is just 4. Divide by negative 4. And 4 divided by negative 4 means that x equals negative 1. So x is negative 1, y is positive 1. So in our parentheses, negative 1, comma 1 for x and then y. And that's our answer for number 5. So far, like I said, I feel like for the most part right now, elimination is probably feeling a little bit simpler than substitution. It's a little bit quicker the way we're doing it right now. We are going to add some difficulty tomorrow with it, but for now, this is all it is. Cross off number 6. We're not doing number 6. All right, let's check out number 7. So we got our x's lined up. We have our y's lined up. We have our regular numbers lined up. So everything is lined up, which means we can go straight to adding or subtracting. So I need somebody to tell me, we're going to add together or subtract this time? We're going to add. Good. I'm going to put a 1 in front of the x and on the top, and I'm going to put a 1 in front of both y's, just as a reminder on the coefficients there. We're going to add them together because this time the numbers with the y's are opposite values, -1 and +1. And when you have opposite values, you want to add them together to eliminate them. So plus. This time we are adding. And when we add them together, 1x plus 3x, that's 4x. -1y plus 1y, that's 0. So those cancel out this time. So the y's are gone. And then 10 plus 18 is 28. So 4x equals 28. Then to solve for x, we divide by 4. 28 divided by 4 means that x equals 7. Move that up so you can see it. So x is equal to 7. Solving for y, first equation or second equation? First equation, all right. So it'll be x minus y equals 10. Well, x is 7, so that'll be 7 minus 1y equals 10. So we're using the first equation to solve for y this time. And then subtract 7 from both sides, get rid of that 7, which will leave us with -1y equals 10 minus 7 is 3. And then to get y by itself, divide both sides by -1. And 3 divided by -1 means that y equals -3. We have x equals 7. We have y equals -3. So 7, comma, -3. That's our answer. Any questions so far? We haven't had to move anything yet to actually use elimination yet. We'll actually see that with the last 3 problems. Number 8, though. Take a look at number 8 real quick. This x is already by itself, right? We're not going to solve this one. And the reason why is this problem here. We could use elimination for this one, and it's telling us to use elimination. I would actually use substitution on this one because the x is already by itself. And since the variable is already by itself, if you have a variable by itself to begin with, substitution is usually the way to go with that because you don't have to move anything around to use substitution here. You can just go directly to substitute. If you were to use elimination on this one, you'd have to move some stuff around. So this one, I would use substitution. We're not going to solve it, but I just wanted to point that out because this one actually sets up, I think, easier for substitution than elimination. All right, moving on. Number 9. Number 9, we don't have a variable all by itself, but we also don't have everything lined up. The x's and the y's are not lined up nicely. The equal sign is not in the same place either. So we've got to do some work here in order to make this actually work the way it should. And as I mentioned on the first page, we usually use elimination when both equations are in standard form. So the second equation here, 5x minus 4y with the x and the y on the left-hand side, this second equation is in standard form. The first equation is not. So we're going to make an adjustment to the first equation and then rewrite both of them to use elimination. So I'm going to rewrite the first equation, 4y equals 2x minus 8. And we're going to get this one into standard form. So we have to get the x's and the y's on the left-hand side. So to do that, it's just one step. We're going to subtract 2x from both sides. So minus 2x from both sides. And when we do that, we end up with x first, then y, -2x, positive 4y, so plus 4y, equals, and then there's a -8 on the right-hand side. So -2x plus 4y equals -8. So now the first equation is also in standard form along with the second equation. So what we're going to do now is rewrite both equations with it stacked and lined up, and then we'll be able to use elimination. So the first equation, -2x plus 4y equals -8. So those two equations here are the same equation, just written in standard form versus this one over here, which isn't in any form right now. And the second equation stays exactly the same. 5x minus 4y equals 20. And if we look now, we can see that the x's are lined up, the y's are lined up, the regular numbers are lined up. And the values in front of y, the positive 4 and negative 4, those are the ones that we're going to be able to eliminate. And are we going to have to add or subtract to make that happen? We're going to add these, yeah. Because they're opposite values, one's positive and one's negative, we're going to add the two equations together. That will eliminate the y variables, and then we'll be able to solve for x. So negative 2x plus 5x is 3x. Negative 4y and positive 4y added together, those cancel out. And then negative 8 plus 20 is 12. So we have 3x equals 12. And then to solve for x, all we have to do is divide by 3 on both sides. And x equals 4. So we solve for x equals 4. Now we need to solve for y. And we actually have a few options here in terms of which one to plug into. We can plug into the very first equation, we could plug into the second equation, or we could plug into the adjusted first equation. I would actually recommend plugging it into the very first equation up here. And the reason is because the y variable doesn't have anything else on the other side of the equation with it, so we wouldn't have to move anything away from the y variable. So let's use the very first equation and plug x equals 4 into that equation. So we're going to say 4y equals 2 times the value of x, which is 4, so 2 times 4, and then minus 8. So we're using the very first equation because we want to solve for y. 2 times 4 is 8. 8 minus 8 is 0. So that's 4y equals 0. Now this isn't going to be a no solution or undefined or anything like that, because 0 is the numerator and you are allowed to take 0 and divide it by numbers. The answer is just 0. So y equals 0. So we have x equals 4. We have y equals 0. So our answer here is 4, 0. And that is the solution for number 9. We are going to solve these last two problems. 10 is actually going to be really quick, and I'll show you in a second what that looks like. Are there any questions on number 9? All right, let's have a look at 10. So 10, everything is lined up. X's over x's, y's over y's, numbers over numbers. So we can go ahead and just get into our elimination right away. Are we going to add or subtract these ones? We're going to subtract them this time. Good. 3x minus 3x, those cancel out. Great. Negative 4y minus negative 4y. What happens with those? Yeah, that'd be negative 4y plus 4y, which equals what? Negative 4y minus negative 4y is the same thing as negative 4y plus 4y. 4y plus 4y would be 8. But negative 4y minus negative 4y or negative 4y plus 4y, what happens? 0 as well, cancels out. X's and y's cancel out, which means on the left-hand side, we have 0. On the right-hand side, negative 10 minus negative 13 would be negative 10 plus 13, which is 3. So take a look. We've got 0 equals 3. Is that a true statement? No. All right, what's our answer then? The variables are gone. No solution. Good. If the variables cancel out altogether, and you have a false statement, you can either write no solution or you can do the 0 with the x through. Either way, no solution on number 10. So we can still see our special cases like we saw with graphing. And if we were to graph these would be parallel lines because parallel lines don't cross. With substitution, it ends up looking like this, where the variables cancel out altogether and you end up with something that isn't true. So these two lines would be parallel. So that's number 10. Nice and quick because the variables are gone with that very first step. The last one, number 11, this is a 2x. I'm going to just make that a little bit easier to see. 2x plus y, I'm going to write 1y equals, that's a negative 10. So 2x plus 1y equals negative 10. And then on the bottom, we have negative y equals 2x plus 10. So first of all, on this one here, our variables are not yet lined up. The top equation, x and y are both on the left. This is standard form. This is kind of what we want when we're dealing with elimination. So the bottom equation is what needs the adjustment this time. So we're going to move this 2x over to the left-hand side. So we're going to take away 2x from both sides of the equation. So minus 2x. And then when you write your equation, write the x first. So that'll be negative 2x minus y, or minus 1y, equals 10. And so now we have x's and y's both on the left-hand side, the regular number on the right-hand side. And so when we write this again, we're going to write both equations again, just like we did in number 9 when we had to make an adjustment. First equation on the top, 2x plus 1y equals negative 10. And then this equation, the adjusted equation, goes underneath that. That would be negative 2x minus 1y equals 10. Now we've got everything lined up. X's and y's are lined up. And should we add or subtract on this one? Yeah, we should add on this one because positive 2 and negative 2 will eliminate when you add them together. Opposites eliminate when you add them. So 2x, negative 2x, those cancel. 1y plus negative 1y, those cancel as well. So again, we have 0 on the left, our variables canceled out. On the right-hand side though, negative 10 plus 10, what does that equal? 0. Negative 10 plus 10 equals 0. So now we're looking at 0 equals 0. Is that true? Yeah, 0 is equal to itself. So what's our answer on this one? Infinitely many. Yeah, it's the other one where the variables cancel out. And because this one was true this time, we write the infinity symbol because there are infinitely many solutions, meaning those two equations end up being the same line if we were to graph it. So that is it for your notes for today. And good news, you have 30 minutes to get some work done.